Have you ever wondered how apps like WhatsApp or Google Docs instantly check if a message reads the same backward and forward, even with punctuation and mixed case? That's the challenge behind LeetCode's Valid Palindrome, one of the top pattern mastery 100 questions and a regular feature in tech interviews. Over 25% of candidates fumble with edge cases here. Let's make sure you're not one of them. A step up from the classic star method, perfect for technical breakdowns. We're given a string and need to determine if it's a palindrome, meaning it reads the same backward and forward, ignoring non-alphanumeric characters and letter case. For example, a man, a plan, a canal, Panama should return true, while race a car should return false. Empty strings, strings with only symbols, mixed upper and lower case, or numbers mixed in. Imagine building a chat moderation tool that checks if users are sending palindromic phrases for fun badges, regardless of punctuation, spaces, or case. You want this check to be fast and bulletproof against any formatting. A naive approach would be to reverse the string and compare, but we'd need to remove all non-alphanumeric characters and normalize case first. We want an efficient approach that also handles gigantic strings without wasting space. Optimal pattern. Use the two-pointer technique, one pointer from the start, one from the end, skip all non-alphanumeric characters, and compare as you go. Time complexity is ON, space is O1 if we process in place. Here's the plan. Initialize 2 pointers, one at the start, one at the end, while the pointers haven't crossed. Skip any non-alphanumeric characters at each end. Compare the characters, convert both to lowercase. If they match, move both pointers inward and continue. If they don't match, return false, it's not a palindrome. If all checks pass, return true. Let's try to implement it using solution 1. Line-by-line narration, line highlighted, class solution. Here we're simply defining a class called solution. This is just a container where our function will live. Pause. Line highlighted, def is palindrome self, str, greater than bool. This line defines a function named isPalindrome, which takes a string s and will return a true or false value depending on whether the string is a valid palindrome. Think of this like naming a little machine whose job is to check symmetry. Pause. Line highlighted, left, right equals 0, lens, 1. Here we set up 2 pointers, one starting at the very beginning of the string, left equals 0, and one starting at the very end, right equals lens, 1. It's like having 2 fingers pointing at opposite ends, slowly walking inward. Time complexity note. Just setting variables, O1, pause. Line highlighted, while left less than right. This loop keeps running as long as our left pointer hasn't crossed our right pointer. Essentially, we'll keep checking pairs of characters from both sides until they meet in the middle. Time complexity. This loop can move each pointer across the string once, giving us ON, pause. Line highlighted, skip non-alphanumeric characters from the left. This comment tells us exactly what the next block of code will do. Ignore anything that isn't a letter or number. Pause. Line highlighted, while left less than right and not s left. Isonym. This line checks whether the current character on the left is not alphanumeric. If it's something like a space, comma, emoji, or punctuation mark, we'll skip it. This ensures we only compare real letters and numbers. Pause. Line highlighted, left plus equals 1. If the character wasn't alphanumeric, we move the left pointer one step to the right, kind of like saying, nope, skip that, try the next one. Time complexity. Skipping still counts toward ON because each pointer moves at most n times. Pause. Line highlighted, skip non-alphanumeric characters from the right. Another helpful comment. Same idea, but now for the right side. Pause. Line highlighted, while left less than right and not s right. Isonym. This checks if the current right side character isn't alphanumeric. If it's something like exclamation mark or white space, we'll skip past it. Pause. Line highlighted, right equals 1, and here we step the right pointer one space to the left, moving inward. Pause. Line highlighted, compare characters case insensitively. This comment reminds us that uppercase versus lowercase shouldn't matter when checking for palindromes. Pause. Line highlighted, if s left, lower, equals s right, lower. We now finally compare the actual letters. We convert both sides to lowercase to avoid mismatches like a versus a. If they don't match, we immediately know the string isn't a palindrome and return false right away. Time complexity. Each comparison is O1, but done up to n/2 times overall ON. Pause. Line highlighted, left plus equals 1. Since the characters matched, we move the left pointer inward for the next comparison. Pause. Line highlighted, right equals 1. And we do the same with the right pointer, stepping it one position to the left. Pause. Line highlighted, return true. If the loop finishes without finding any mismatched characters, then the string is indeed a palindrome, so we return true as our final result. Pause. Final wrap-up. And that's how this algorithm works. It first sets up 2 pointers, then moves them inward while skipping non-alphanumeric characters and comparing the meaningful ones. Efficient, simple, and elegant. Highlight input box. S equals a man, a plan, a canal, Panama. Let's test our function using this string. A man, a plan, a canal, Panama. This is a classic palindrome phrase that includes spaces, commas, and a colon, along with both uppercase and lowercase letters. Explain the logic briefly. Our algorithm ignores all non-alphanumeric characters and treats letters in a case-insensitive way. So this input is effectively turned into a mana plana canal Panama. If we compare characters from the start and end moving toward the center, every pair matches, so the clean string reads the same forwards and backwards, exactly what defines a palindrome. Highlight output box. Output, true, expected, true, and that's what our program returns. True, which matches the expected result true. So, our implementation is correct. The algorithm successfully finds the maximum profit in a single pass through the prices, efficient and accurate. Now let's try another implement approach using solution 2. Line highlighted, class solution. We begin by creating a class called solution, just a container to hold our palindrome checking method. Pause. Line highlighted, def is palindrome self s. This defines our function as palindrome, which checks whether a given string reads the same forwards and backwards after we clean it. Pause. Line highlighted, hash build filtered string with only alphanumeric chars in lowercase. This comment explains the plan. We're going to build a clean version of the string that contains only letters and digits, all in lowercase. Pause. Line highlighted, filtered equals. Here we create an empty list called filtered. Think of it as a small basket where we'll store only the useful characters from the input. Pause. Line highlighted, for char in S. This loop goes through the string one character at a time. Time complexity. This loop inspects every character on. Pause. Line highlighted, if char.isolnum, we check if the character is alphanumeric, meaning it's a letter or a number. Spaces, punctuation, and special symbols are ignored. Pause. Line highlighted, filtered.append char.lower. If it is alphanumeric, we convert it to lowercase and add it to the filtered list. This ensures case doesn't affect our palindrome check. A and A are treated the same. Appending is O1, so across the whole loop we remain at ON. Pause. Line highlighted, hash check if filtered list equals its reverse. This comment tells us the final step. Compare the cleaned version of the string to its reverse. Pause. Line highlighted, return filtered equals filtered. -1. This is the key comparison. Filtered is our cleaned sequence of characters. Filtered, -1, creates a reversed copy. If both lists are identical, the string is a palindrome. Otherwise, it isn't. Creating the reversed list is ON, and comparing the two is also ON. Overall time complexity, ON. Overall space complexity, ON, because we store the filtered list and its reversed copy. Pause. Final wrap-up. And that's how this algorithm works. It first builds a filtered lowercase list of only alphanumeric characters, then checks whether that cleaned list is equal to its reversed version. Efficient, simple, and elegant. Highlight input box. S equals a man, a plan, a canal, Panama. Let's test our function using this string. A man, a plan, a canal, Panama. This is a classic palindrome phrase that includes spaces, commas, and a colon, along with both uppercase and lowercase letters. Explain the logic briefly. Our algorithm ignores all non-alphanumeric characters and treats letters in a case-insensitive way. So this input is effectively turned into a mana plana canal Panama. If we compare characters from the start and end moving toward the center, every pair matches, so the clean string reads the same forwards and backwards, exactly what defines a palindrome. Highlight output box. Output, true, expected, true, and that's what our program returns. True, which matches the expected result true. So, our implementation is correct. The algorithm successfully finds the maximum profit in a single pass through the prices, efficient and accurate. Let's wrap up valid palindrome. A deceptively simple question that tests your attention to detail and mastery of two-pointer logic. The task was to check if a string reads the same forward and backward, ignoring punctuation, spaces, and case sensitivity. It's about comparing structure, not formatting. We compared two main approaches, cleaning and reversing versus using two pointers. The two-pointer method won for efficiency. Scanning from both ends while skipping non-alphanumeric characters gives us ON time and O1 space. Our plan was simple: move two pointers inward, skip invalid characters, compare lowercase letters, and stop early if any mismatch is found. We translated that plan directly into code, using clean pointer movement and case normalization, and it executed perfectly on LeetCode. Tests like a man, a plan, a canal, Panama returned true, while race a car returned false. Edge cases like empty or all space strings also passed as valid palindromes. The takeaway? Two-pointer strategies aren't just for arrays, they're powerful tools for string analysis too. Once you master this flow, you're ready for problems like valid palindrome 2 and longest palindromic substring.